Good day, everyone. I am Henry Aidenry Isaludo from BSIT 3A, and today I will be discussing an important networking concept. What happens as a packet travels from one networking device to another? This process is the foundation of how data moves across networks, from the sender to the receiver. To make it easier to understand, let us look at three key parts: the IP addresses, the MAC addresses, and the TTL value. The first point is that the IP addresses never change. The source IP belongs to the sender, and the destination IP belongs to the receiver. For example, in our diagram, the source IP is 192.168.1.10, which belongs to PC1, and the destination IP is 192.168.4.10, which belongs to PC2. Even when the packet passes through several routers such as R1, R2, and R3, these IP addresses remain the same from start to finish. The second point is that the MAC addresses change at every hop. Routers only use MAC addresses to deliver data to the next directly connected device. For example, from PC1 to R1, the source MAC is PC1's MAC, and the destination MAC is R1's MAC. Then from R1 to R2, the source MAC becomes R1's MAC, and the destination MAC becomes R2's MAC. The same happens from R2 to R3, and finally from R3 to PC2. This shows that at every hop, the old MAC address is removed and replaced with a new one. The third point is the TTL, or time to live. TTL is a countdown value inside the packet that limits how many hops it can take before being discarded. The starting TTL depends on the device's operating system, usually set to values like 64, 128, or 255. Each time the packet goes through a router, the TTL decreases by 1, and if it reaches 0, the packet is discarded. This mechanism prevents packets from looping endlessly in the network. To make this easier to imagine, think of sending a letter through different delivery trucks. The IP address is like the home address written on the envelope. It never changes. From PC1's house at 192.168.1.10 to PC2's house at 192.168.4.10. The MAC address is like the delivery truck label. It changes every time the letter is handed to a new truck, just as it changes at every router. And the TTL is like a timer on the package. Each post office decreases the timer, and if it runs out, the package is thrown away instead of moving forever. As a packet travels across the network, the IP addresses remain constant from end to end. The MAC addresses change at every hop, and the TTL ensures that packets do not travel endlessly. This entire process shows how routers keep the packet moving closer to its destination, while also keeping the network efficient and safe. Thank you for listening. This is Henry Aidenry E. Saludo from BSIT 3A.